Okay, I wanted to look at a couple of the even numbered problems from the homework, just because this idea of finding the integral, the antiderivative, has been a little while since we did Calculus 1, and some of those derivative rules might not be easy for you to reverse. And we're going to get more tools for that soon. At the moment, they're just tossing you in and letting you flounder about with it. But let's try number 22 to start with. So 22, they want you to find the area under this curve from 0 to 4. And I don't even know what that curve looks like. I could draw it on the calculator. But whatever it looks like, I'm then going to shade underneath it from 0 to 4. So it's some sort of quadratic, right? And we'll go 0 to 4, and we will try to find, I don't know if that's the right drawing. It's probably not. But we'll try to find the area from 0 to 4. Okay, so that's the basic idea, but we don't need the picture necessarily anymore because we have this strong algebraic connection. And we just need to find out what the antiderivative is and then plug in 0 and 4 and subtract the two results. So looking at that, you have to ask yourself, what is the antiderivative of 1? What function, when you integrate it, would you get 1? Or sorry, when you differentiate it, would you get 1? And if you think about the derivative of x, the derivative of x is 1. So that works for that part. And when you think about the function 3y, that's maybe a little more difficult. You know that the y part will have to have come from a y squared, right? Because that's how derivatives work. As the power comes down and the power decreases by 1. So if this had said 2y, we'd be in great shape because that'd be just the derivative of y squared. But that 3 there is not exactly what I wanted. But consider this. Let's keep the 3 there. I'm going to put a 2 there. And y squared. Now when you take the derivative of 3 halves y squared, the 2 would come down and cancel the 2 there, and you'd get 3y. And again, that's exactly what we wanted. So we've taken care of the 3y part. And for the minus y squared, again, we know a second powered thing had to come from a third powered thing. But normally when you take the derivative of y cubed, the 3 would come down and there'd be a 3 right here in front. There isn't over here, but I can put a 1/3 right there. And now the derivative of 1/3 y cubed, the 3 would come down, the 1/3 would cancel it, and you would just get plain old y squared. So if these derivative rules that I'm reversing seem a little bit uncomfortable, I'd encourage you to go back and look over some of the derivatives in Calc 1. But definitely for the moment, just convince yourself that if you took the derivative of this, you would get back to that. So that is the function that I need to plug my 4 and my 0 into. And sometimes to indicate that, you just say, okay, I've got the antiderivative, I've got the integral, but I haven't plugged in the numbers yet. So sometimes they just use a little vertical line right there, and they say, okay, I haven't plugged the numbers in yet because I was just too busy trying to figure out what the actual function was, and now I'll plug in 4 and 0. So 4 plugged in would be 4 plus 3 halves 4 squared minus 1/3 4 cubed. And that was just plugging in 4. And we still need to do minus plugging in 0. Normally that would create 3 more terms, and I'd have to be careful to do minus all 3 terms. In this particular case, plugging in 0 just gives you 0, 0, 0. So I'm just going to jump the gun right there and say plugging in 0 to all 3 of those terms. Oh, I see I used an x right there. That should be a y also. Just gives you 0, and we just need to finish crunching the numbers here. So let's see. We've got 4 plus 3/2 times 16 minus 1/3 times 64 minus 0. So this crunches down to 4 plus 24 minus 64 thirds. So let's keep going. So this will be 28 minus 64 thirds. And really, probably if you look in the back of the book, they're going to take this all the way down to a single fraction. So let's see, 28 times 3 would be 30, 90, 84 thirds, right? You might need to double check my arithmetic on that. I don't have a calculator in front of me right now, but if I did that right, the final answer for this problem would end up being 20 thirds. Okay, so that's kind of doing a polynomial. And let's see, we did one like 28 already, that was cosine, but I wanted to take a look at number 30. So let me give myself a little bit of room here. I'm going to get rid of these last few numeric computations. Okay, and let's look at number 30. And the only reason I want to look at number 30 is it may not be very obvious right away. What function has the derivative 1 over square root of x? And in calculus, we often don't like square roots. So I'm going to do a little bit of rewriting here. I'm just going to say this is 1 over x to the 1/2. And I'm even going to rewrite this one more time and just say this is, because 1 over with a power, we know is the same thing as x. It's negative 1/2. And maybe now it's a little bit easier to figure out what function has a derivative of x to the negative 1/2. Now we know how derivatives work, so we know that the power must have decreased by 1, so I'll increase it again. Go back to x to the 1/2. And again, normally when you take the derivative of x to the 1/2, you would subtract 1 from the exponent, so you'll definitely get the negative exponent, negative 1/2 exponent. But this 1/2 would come down front. We don't see that here. So apparently there must have been a 2 right there. So now you take the derivative of 2x to the 1/2. The 1/2 comes down, multiplies the 2, those cancel. And you just get x to the negative 1/2. So we found the proper antiderivative. And we just need to plug into that 4 and 1. So I'm going to move down here. So plugging in 4 would give you 2, 4 to the 1/2 minus, and then we'll plug in 1. 1/2 power means square root, so this is square root of 4 is 2, so 2 times 2 minus 2 times 1. So this is 4 minus 2, so ultimately area under that particular curve from 1 to 4 is 2.